Okay, this lesson will give you some practice problems as far as how to do the vector application practice problems. I'm just going to do 1 and 1B, and if for homework do 2, 2B, and then on the back the vector application problems. But let's take a look at this problem right here. It says a hurricane is traveling 47 miles per hour at 35 degrees north of east. So if we just sort of draw that, here's what it would sort of look like. I'm not going to draw it to scale or anything like that. Got my hurricane here. And it's going to be going northeast, and this is a 35 degree angle here, and I'm going to put 47 miles per hour up here because that's how fast it's going. And it wants to know how far north it will have traveled in 3 days. Okay, how far north will it have traveled? So what I want to know is this. I want to know the distance in the north direction. Well, let's not forget a few things here. Remember those old triangles that I taught you in the first chapter, that velocity equals distance divided by time? Well, the key with these formulas, they all have to be in the same direction. In other words, if I wanted to figure out how far north I was going, I couldn't use that 47 miles per hour because it's both going north and east. So I have to figure out how fast is the hurricane going just in the north direction. So I'm going to rewrite this formula. I'm looking to figure out how far north, so I'm going to put distance in the north direction is going to be equal to the velocity in the north direction times the time. Now, time doesn't have any direction as of yet, so we'll just put down time like that. So if I want to find the distance in north direction, the first thing I got to figure out is how fast is this hurricane moving just in the north direction. Well, if you notice the vector I drew here, I divided that resultant, the 47, into its vertical and horizontal components. And so the velocity in the north direction is this opposite side of the right triangle right here. Well, let's not forget our SOHCAHTOA stuff. Remember the sine of theta equals opposite over hypotenuse? So if you want to find the opposite side, which is equal to the velocity in the north direction, that's going to be equal to the sine of theta times the hypotenuse. So that's what I'm going to put up here, and I'm going to plug that in for V. So I could say that the distance in the north direction equals the sine of theta times the hypotenuse times the time. So let's go ahead and plug all this stuff in now. And what I'm going to have here is the distance in the north direction is going to be equal to the sine of 35 degrees times the hypotenuse, which is 47 miles per hour, times the time, which is 3 days. Now, I can't use 3 days because this is in miles per hour. So I got to switch that 3 days, knowing that there's 24 hours in 1 day. Do my little railroad tracks or conversion factor. So that gives me 72 hours. So I'm going to put 72 hours down here. And you know, the other thing I should have done, instead of writing it like this, I should have wrote that as 47 miles over hours. That way you can see how the hours here are going to cancel. And you're just going to be left with the answer when you do this on your calculator. Now make sure you got this in degree mode of 26.95 miles. And if you just use significant figures, it's going to be 27 miles. Okay. Now to do part B, now it says how many days, so I'm looking for time again. So I'm going to use that same triangle, velocity equals distance over time. But now it wants to know how many days will it travel 2,000 miles west to east. Well, that means the velocity, I can't use the north velocity. I can't use the 47 because it's going north and east. I've got to figure out what is it just in the east direction now. So going this way. So this is my velocity in the east direction, or east-west direction. Okay. So I'm going to write down my formula of how many days would be t equals distance in the east-west direction. I'm just going to put an EW for east-west direction, and the velocity in the east direction, east-west direction. So if you come back up here, if you notice now, you're wanting to find the adjacent side of this right triangle. Well, if you're trying to find the adjacent side, don't forget, once again, SOHCAHTOA, the cosine of theta equals adjacent over hypotenuse. So the adjacent side can be found by taking the cosine of theta times the hypotenuse. And so that's what I'm going to fill in for the velocity. So that means the velocity in the east-west direction equals the cosine of theta times the hypotenuse. Okay, so let's fill all that in now. I'm going to take t equals 2,000 miles and divide that by, once again, I'm going to fill this part in up here for the velocity. So I'm going to take the cosine of theta, which is 35, multiply that by my hypotenuse of 47 miles per hour, and that gives me a time of 51.9. Now remember, the miles here cancel out with the miles there, so you're left with hours. But you don't want to know hours. The question up here asks how many days. So I got to divide 1 day by 24 hours. Again, make sure you show all your work. And so my time will end up being 2.16 days, or with significant figures, 2.2 days.